Hey everyone, Chill here with Prismatic Powders, and today we have a video for the nerds. Just kidding, it'll be cool if you're a nerd. I'm a nerd too. Today we're going to discuss the topic of adhesion. What makes the powder stick? What creates that bond, and why is it important? Please like and subscribe, helps keep the channel going, and hit the bell for notifications each time we upload a new video. Now then, in the entirety of the powder coating process, we rely on two kinds of adhesion. Initially, you want the kind of electrostatic adhesion that takes place as the powder is transferred from the gun to your metal parts. And this is what you are observing with transfer efficiency, which is basically a fancy term for efficiency of the electrostatic process that is taking place as the negatively charged powder finds its pathway to ground, aka your parts. The grounded parts are acting as a collection place for those negatively charged particles. So in order for this process to happen, obviously your parts need to be grounded, and of course you need to charge the powder. The ideal amount of charge can vary from material to material and powder to powder, among other things, which is why it's very helpful to have a system where you can tune this charge and the density of the powder cloud that comes from the gun. When you get it right, you have good transfer efficiency and therefore good electrostatic adhesion, and the powder adheres and builds on the part predictably and evenly. Now, when the application process is over and it's time to get your parts into the oven, you're going to rely on another adhesion process, and that is mechanical adhesion. Mechanical adhesion is what is taking place at the surface level of the substrate, resulting from your blast profile. If you've properly prepped and blasted your parts with the right grit and the right pressure, you're going to have an ideal blast profile that allows the powder to melt into all those tiny little indentations and nicks on the surface as the powder on the parts begins to melt in the oven. And as those parts cool, the powder hardens and it's locked into place. The combination of having a relatively thick coating that is also flexible, that is mechanically bonded to the surface, is what gives us the very resilient, durable coating we all love. So, in summary, we've got two kinds of adhesion, both are very important, and the end result will be the sum of the two processes because you're essentially marrying the two kinds of adhesion together once your parts go in the oven. And like a good marriage, both are equally important, so it's important to give careful attention to both types. Make sure you get your settings dialed for the powder and material you're coating for that electrostatic adhesion, and be diligent when it comes to part preparation and sandblasting because it's essential for the mechanical adhesion. Okay, that's it for this video. Hopefully it explains the importance of these two kinds of adhesion processes and helps you explore them and get them dialed in your own workflow. Thanks for watching. We'll see you in the next one. Good night. Good night, New York. No.